time for Nerdgasm.
Hey, what's up guys? Jerry here, aka Barnacles, and I'm out here in my makerspace, and today Zachariah and I are finally gonna assemble the X-CARVE CNC machine from Inventables. Now this is basically a 1 meter by 1 meter 3-axis CNC machine that'll cut just about anything, except for like for hard metals and things like that. You do need to put a more powerful motor on it, but it is capable.
Yep.
So yeah, apparently this thing is a big pain in the ass to put together, but I got him. He's done it before.
That I have.
So hopefully this is gonna go smoothly and you guys are gonna see a lot of time lapse because apparently there are a lot of repetitive operations.
It'll take quite a while.
Yeah, so sit back, have some popcorn, and laugh at two fatties building the X-CARVE. And yeah, I just called him a fatty. All right, guys, we're ready to open up box number 1 right here. Ooh, look at that, a letter from Zach Kaplan, the founder of Inventables, saying, you have an X-CARVE. All right, so what do we got here? We got a box. Look at that beautiful pack job that they did right there. All right, so what's the first thing we have?
The first thing is some material. 1 foot by 1 foot material to start you off.
A material bundle.
This is a nice little bag of tools.
Oh my God, it comes with the tools to assemble it?
It comes with the tools to assemble it.
Wow.
Though we're gonna need to use your drill.
Not a problem, not a problem.
Stepper motors.
Ooh yeah, beefcake.
This is the motion controller, so the Arduino and all the other parts for it. Wiring to connect all the big parts together. Clamps for us at the ends to be able to clamp material down onto the board.
The clamps.
Drag chain. Digital caliper. Lead screws.
Components.
Ooh, core components box.
Power supply.
300 watts of beefcake.
And this is the quiet spindle. This is the same one that I have. This is the mount for the motor. We'll put that. Actually, we can
Let's put the motor back in there. Trying to keep everything organized because we're basically building a kit from scratch here.
Yes.
I mean, all the parts have been cut and designed to fit together, but this is 100% us assembling it.
So there's a starter set of bits, end mill.
Ooh, end mill bits. And limit switches so that the motors don't go. All right, we done with this box?
We are done with that.
You're gonna spend a lot of time on your knees today.
Jerry, if you're gonna make me spend that much time on my knees, you gotta at least give me garden pads.
He's gonna spend a lot of time on his knees today.
So one of the first things we are gonna wanna do is sort everything, kind of like when you do Legos, because otherwise it's gonna be a pain in the ass to find all the parts. And what I found was this spindle box is the perfect size to fit all of the little nicely packaged and labeled Ziploc bags.
All right, guys, so the directions that we're going to use to assemble this are actually on Inventables' website. You can see we're just using a little Dell XPS giant tablet thing here. And these are the directions we're going to be following. There will be a link in the video description, so if you guys want to follow along with the video and see what we're doing, these are the instructions we're going to be using.
First, we should make sure we have all the parts. Here's a good example. This number is slightly different, 25203-01, and yeah, these are the dual bearing V wheels. I know. These are the ones.
So some of the parts have changed out. So like on the web page, it specifically has the core component list, and it lists a different part number than this, but it's just a revised version of the same part.
So these are the eccentric nuts. We're gonna need the eccentric nuts.
In the bowl?
Yeah, put them in a bowl.
Okay.
So you have a Sharpie I can mark off on the list of?
I'll show you my eccentric nuts. Sorry.
That's one drawback of having instructions online is you can't take a little pencil and check off.
Well, no, we could use a dry erase marker, but then if you scrolled, we'd be really screwed.
Here's a good example is it just says aluminum spacers, not the really long instruction.
Yeah, so the part number is correct, but the name actually doesn't match what's on the page. So again, just be aware, try to match up the name or the part number, or at least verify that it looks the same as the part. So we're building this.
We're building this.
We're building this, guys. So we're gonna go ahead and time lapse this part because this might take a little while.
Yes, it will take a while.
Well, we decided that we're actually going to use a drill instead because this thing has like a million little nuts and bolts. So let's go ahead and work smarter, not harder, right? Oh, tighten her up a little. All right, guys, so we got the carriage built. Now we need to put some motors on it. So here I have the NEMA 23 big boys, and we need to mount just one.
Just one of
them. To the carriage. There you go, sir.
Thank you, sir.
The carriage is finished.
Na, 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 na.
Alright, now we move on to the Y plate.
Alright, so here's our 2 Y plates.
2 Y plates.
We are building some Y plates now. Let me know when you're done.
Alright.
Hey guys, somebody wanted to come out and say hi and see what we were up to.
We're up to a drilling garage store up to, and you know it, and we just have a phone call. And we have a drilling sweeper, a master-sized drill, and
This is my life. 24/7.
and a size computer, and
Oh yeah?
we have a dressed up stormtrooper. Then we have
Okay.
a straight trading poop.
Oh, trading poop, huh? All right, so one of the things I did was actually shorten the wires right here because you can see it came with a massive amount of excess on here. So instead of wadding it up and trying to contain it with tape or something like that, we just cut them down so that they fit nice and perfectly, and it just keeps everything nice and neat. And I could even put some split loom or something on there to make it look really, really nice. All right, we are on to box number 2 of 3. This is a very slow process. Don't you point that thing at me. All right, so now we got to attach the Y plates to the end of the aluminum extrusion. Now, one of the weird things about this is it's self-tapping screws that actually drill the heads into the aluminum extrusion. They're not pre-tapped. So you have to be very, very careful here. So we got our lube, our WD-40,
Wow.
and we're gonna lube them screws. And then we're gonna twist them in nice and slow.
Ladies.
All right, so we've completed the top gantry now. So here's the piece. This slides back and forth that actually carries the engraving tool itself, the little spindle. And then on the sides, we have the plates with the stepper motors that move it on this axis. So now we have to build the rails that this thing rides on, and then ultimately those rails attach to the base. So we still have a long way to go. We've been at this now for a little over 5 hours, and that's even with him knowing exactly what he's doing and sorting all of our parts out and everything. So definitely put aside 1 or 2 days for assembling this project.
But oh my god, is this thing gonna be worth it? Ba, ba, ba.
All right, guys. Well, we went ahead and put all of the screws in. They're self-tapping, so if you are going to use a drill like we did, I highly recommend you use a high-quality precision drill with a low-end gearbox that you can move very, very slow. If you try to drill them in too fast, you will strip them out. They will overheat and break. Also, make sure you use a lubricant. Well, I don't want to call it a lubricant, but use WD-40 or some kind of oil, penetrating oil, on the threads just to hedge your bets. Because you'd be pissed if you spent all this money just and stripped out one screw, because the structural stability of that is key to the accuracy. All right, we've just added the straps and tensioned them. Well, it's starting to look like a CNC machine. Woohoo! Looks like we got the Z-axis screw going in right now, so that's where the last motor goes, and that operates your mechanism up and down. All right, we're making huge progress on the wiring here. We have all the little 12-foot cables all marked up with pen. All the wires are twisted and cut to length and run through this bar here. So right now, we've got wires to go places. Now we just got to get them to those places so this whole thing will work. So we're getting close. All right, Vanna, so now we're running all the cables through the cable chain here. And so that includes the cables to power the 2 stepper motors that come off the main block and the end stop switches. So good stuff. The idea is we cut all these cables down to length, and in the instructions it tells you how to do all this, but if you take your time and trim them down, yeah, you don't want that much excess. Look how much cable that is.
Well, they will go through the other drag chain.
Oh, they do have to go through the other chain?
Some of them will, yeah.
All right. Well, we're going to get this done because we've been at this for a very, very long time. But honestly, we're actually making good time compared to your previous build, right?
Oh, yeah. We're about almost 8 hours, but I think we were probably about 10 or 12 by this time.
See, guys? See what happens when you get professional help? All right, Zachariah is now going to insert the carriage. Insert it. Stick it in there. Yeah, give it to her good. All right, so you have to gently stick the screws in the holes and twist them ever so gently while paying great respect to the threads as not to strip them. Okay, so she's on there. So now we got a Z-axis, an X, and a Y-axis. So what's next, Zachariah?
Next, we insert the spindle.
Alright, so this is the Inventables board. This is basically the foundation of the carving machine and also allows you a margin of error. The bit can actually safely transfer into this, whereas if you had the giant metal on the bottom, you might have a bad day. Now, the insides of these guys are threaded. So the idea is you put these down through, and then on the other side, you can actually thread a screw through for actually clamping down the material to the surface that you're working with. Alright guys, you definitely want to take your time squaring this up and making sure that you have the same distance off both sides here before you tighten everything down, because there's a lot of little things that you tighten down. If you don't get it right, you have to take it all back apart again. And then we have to attach this to it in the next step. And of course, if this isn't all measured properly and squared up, you're going to have a bad day. Isn't that right?
Gonna have a bad day.
Gonna have a bad day. Also, today's show is brought to you by Sierra Games, the creator of such awesome games as Leisure Suit Larry 1 and Leisure Suit Larry 2. Those are the games that raised me up as a kid, and you can probably tell if you watch my videos. All right, let's flip her over. Ugh. This thing's starting to get a little bit of weight to it. Let's sit her down. All right, show them how you feed all them wires through that drag chain. Now guys, cool little pro tip when you're trying to feed these through the cable. Take a zip tie, tape it around all the cables at the very end so that there's no snags, make it really smooth, and then just feed the zip tie down through, and you can pull a whole bundle of rat nest wires like this through there with minimal difficulties. There you go. You're really tight. Yeah. See that? Yeah. That's how you do that. It's worth watching this video just for that one tech tip. All right, so here's what the drag chain looks like assembled on here. We still have to run one more cable through it because we forgot. But it kind of gives you an idea. You got the top drag chain here, so this can move back and forth, and then this one allows this to move back and forth without you having a rat's nest all over the place. It's actually pretty cool. All right, now they don't include this stuff in the kit. It's actually just called split loom. It's for covering up all the wires. I'm just going to go ahead and add it. It's not necessary for the machine to work, but I just figured while we're at it, let's make it a little purtier. All right, so just have to hook up the final wire coming out of here onto this block, and you do have to double it up with the wires on one side. So let's go ahead and do just that. Dude, that looks great.
It does.
Look at that. We're good.
Yeah.
Rock on. Now, one of the things I don't like about the design of this thing is that all the electronics, the power supply, the brain, and everything are just dangling off the side of it with wires going everywhere. So a little bit later on, I'm going to try to find a better solution to attach all that stuff to the main unit or make it easy to disconnect so that when you're not using the machine, you can just take it all off and store it. I'll show you exactly what I mean once we get it all wired up. All right, guys, so the power supply just comes with a little screw header here, and they actually give you this terminal that gives you an on-off switch, power, and everything, so you don't have to wire all the wires directly to that. So that's nice, and then we have to put a shroud over it, so let's go ahead and show them that. So it does
First, you have to pull those off.
Okay, so those come off. That's where the wires go into, and then the shroud goes over it just to protect everything and make it look a little nicer. And then you said, what is the Arduino board going up there?
Yep.
To kind of keep it all together, but still, you got wires all over the place with this thing. Okay, so here we have the G-Shield. This is the unit that actually connects to the stepper motors and then plugs into the Arduino board. And all that stuff gets stuffed in this little hole. So we do have to do a little bit of soldering now. All right, well, this thing does require some extremely delicate soldering, which I wasn't expecting. So this little block right here feeds down through the top. That is really delicate soldering. If you don't know how to solder, practice on something first before doing that.
I'll be honest, I screwed a couple things up and I probably edited it out. But don't worry, it's fixed now.
All right, guys, so they give you these little terminal pins that you have to put on some of the ends of the wires. And they actually say in the instructions for them to use a crimping tool. Well, I don't have a crimping tool, and they didn't include a crimping tool, and I don't think that's something that common that everybody has. Correct me if I'm wrong there, but in this case, I'm just using a good old-fashioned pair of pliers to crimp them on there and fold the little ears over. So just take your time. If you don't have a crimping tool, it'll work just fine.
All right, so we need to wire up the cables for each of the different axes.
Okay,
now,
which one's the first?
It goes, you can see on the board here, it says X, Y, and Z.
X, Y, and Z. So I'm going to assume that's Z.
Yep.
That's X.
Yep, and then this is Y.
So we're going to start with X. All right.
And it goes in the same order as before from this direction: red, white, green, black.
Red, white, green, black?
Yes. Now, don't have a bunch of excess wire off the end of them, because they're going to be sticking out and moving around a bunch, and you don't want them shortened.
Now I got to screw down the Arduino board. You just make sure it's aligned so that the little USB port is poking out the side. Oops. And try not to knock everything off the desk in the process. This is a very involved process. Like, I would probably shoot myself if I worked at a place that had to assemble these all day. I probably would. The only thing I don't like is look how much further that side sits down than that side right there. But that's because that's blocking. Were we supposed to have that up a little bit more before I soldered it?
I don't think
I mean,
so.
the pins are making contact either way, so I think we're okay.
Yeah.
It just, if you look at it down in there, you can see it's at an angle. You can tell the
yeah.
pins on this side are not pushed down as far as the pins on this side.
Yeah. No, I completely.
All right, we're gonna go ahead and call that good for now, and if it isn't, well then I'll
It's not good.
just bend these up a little bit. All right, so I went ahead and wired up the fan right here, and you do have to twist the wires together. This one that goes to this little terminal right here that we're trying to figure out. So there is a lot of stuff you got to wire up in here, and one suggestion I'd have is don't put the fan mounted on just yet. It comes with a bracket to mount it on the top. I wouldn't put it on just yet because you want to test all this stuff and make sure it works. Because otherwise you're gonna just be taking it apart again. So we're gonna try to test it as is. I just would like to go on record and say that this is a complete mess. Wiring up this little connector, all the little soldering you have to do there, having to put 5 wires twisted together into one ground on the Arduino daughter board. I'm gonna say that this is probably the worst part of the entire design right here, and I hope that at some point Inventables addresses this, because I mean, I can't imagine that the regular user is just going to be able to put this together and not have problems. We do have it together. We're going to do some testing now, but just having all the wires shooting out from all these different positions and having to twist and solder 5 wires together going into one terminal, I would highly recommend actually just throwing this away if I had to do it over again, and then going getting actual like spade connectors and everything like that, and just putting 1 wire from each terminal and going that route and cleaning it all up. Because this right here, I mean, it's just, I mean, this just looks like a mess. And this is how they tell you to do it. All right, guys, we went ahead and put some loom over the cables just because that thing was a complete rat's nest. So now it doesn't look as bad. Now it just looks like we have a single cable coming off there. But again, I would say if you're spending this much time to put this together, I would ahead of time go get a bunch of quick disconnect cables and you know, some wiring and little spade connectors and everything, and actually do this really, really clean instead of just pressing all the wires into the blocks and screwing them into place. It'll just look a lot better, but this doesn't look bad now that I put some loom on there. So worst case scenario, just pick up $5 worth of loom at your local hardware store, and that'll help a little bit. All right, I got my boy Zachariah over here installing the software on my Dell XPS 17-inch tablet, and that's what I'm going to use to drive the X-CARVE out here in the Nerd Cave. I like to call it the maker space, but let's be honest, it's just a garage. All right, we are about to fire this up for the first time. We just plugged it in. The first time ever hitting the power. Let's see what happens. Oop, I hear a fan.
There it is.
Arduino Uno COM3. Woohoo!
Alrighty.
All right, so now we just got to install Java and get the software to link up to this thing, and then we'll go to the next step. One side is stepping one way, and the other side is stepping the other way. So we have a stepper motor somehow reversed somewhere. So now the troubleshooting begins. All right, guys, we fixed it. Now everything is moving in the correct direction. What it was is we had to wire one of the stepper motors backwards on the side, and it's really easy to miss things in the instructions, guys. There is a lot of stuff in there, so pay close attention. But one thing I would love to stress is when you fire this thing up for the first time, make damn sure you're doing it in small increments. Right now he's doing it at 100, literally do it in 1. If we had said do large incremental movements with that motor backwards like that, we would have had a really bad thing happen, and it may have broke some stuff. So, again, guys, this is definitely a complex project. Take your time. All right, guys, check this out. We did find another problem. Notice when he moves it, do it again. It makes this like loud noise and it stops moving. The stepper stops moving. Well, we figured out that it's actually the potentiometers here in the box on the Y-axis. You have to turn it up just a touch using the little flathead, just 1 notch. Now go ahead and run it again. And now it's smooth and it doesn't do it anymore. Now, we don't know if this is in the instructions or not. This is something that you actually figured out on your X-CARVE, and we had the same problem with ours. And I think you figured out by going to the forums, wasn't it?
Yeah, I went to the forums and somebody was nice enough to help me out.
So if you guys have problems, check out the forums. But this specific problem, if you're moving on any of the axes and you notice that the motor just stops and starts making noise, try turning up the potentiometer just a little bit on the Arduino daughter board, and it may correct the problem. All right, guys, we're getting ready to do our very first cut. We've got the machine calibrated. We tightened up all the bolts. You can see here they have these little latching mechanisms right here that lock the board down. We just grabbed a piece of scrap plywood that I had and put it down. So now in the software, we're going to do a little demo cut that actually says Jerry across it. It's just a little demo thing. It's the first thing you do when you install the, is it Easel, the software?
Yes,
it's
Easel.
Which is a pretty cool, easy to use app. It's funny, this thing is ridiculously hard to put together, but the app is dead simple. So hey, there's that. All right, so we're going to go ahead and install the first bit here. What size bit is this, sir?
This is a 1/16 of an inch.
1/16 of an inch. Now, again, in the software, you tell the software what bit you're putting in. And just like with the 3D printers, it shows you red to indicate if the bit is incapable of doing what you're asking it to from the design. So we're just using this little bit right here because this works perfectly for the little demo that they had. If we put a bit any bigger than this, we would actually have some problems with the final result coming out the way that it is on the screen. So you have to be conscious of a couple things definitely when you're doing this. But I think we're just about ready to go, right?
We are.
I'm excited. This has been like 2 full days of labor over a couple of weeks to get this done. Alright guys, here it is, the finished product. We got Xander cut out of plywood. You can see that there's just a tiny little mark on the surface. That's why they call this the waste wood, basically, you know. So it cut it out. It just had little tabs here on the corner so that you could easily just break it out of the wood when you're done. Alright, let's try a little wood stain and spruce up this little piece of garbage wood that I found in my garage. Then you gotta realize, guys, this just started off as a little piece of scrap plywood that I was actually gonna throw away. Because it wasn't nice, it wasn't anything you'd make a shelf out of. It was heavily splintered.
Yeah,
it was warped. We literally had to use the clamps to hold it down level so that we could even, like, get it. And now we're just using a little stain that I had left over from a project I did probably 4 years ago. Just stain that I just had sitting on the shelf. And I mean, now we just took a piece of plywood.
That is awesome.
And made it that. Hey guys, I hope you enjoyed this video. Please take a moment and subscribe to my channel. It helps me a lot. Also come over to Twitter. I'm @Barnacles. I'm a real social guy. Also, if you have a couple of minutes, check out some of these many other videos. I made them myself.